This video introduces several wideband compact antennas enabled with interdigitated magnetic near-field resonant parasitic elements. Comparisons of two kinds of antennas based on magnetic near-field resonant parasitic elements were introduced. This first one is an intact near-field resonant parasitic loop element excited by a driven dipole. It resonates at 0.78 GHz and has an electrically small size with K equals 0.65. When this intact near-field resonant parasitic element turns into an interdigitated one, it then has two nearby resonates but remains electrically small with K equals 0.8. While the electrical size has slightly increased, its calculated Q ratio value becomes much smaller, indicating a good bandwidth enhancement. The surface currents on the interdigitated near-field resonant parasitic element at the lower frequency point are basically the same as those of the intact one, confirming that it is operating in its fundamental mode. And at the higher resonance frequency identify that it is operating in its first higher order mode. It is also clear from the bottom right plots that these two resonances have reasonably stable realized gain patterns. With the operating principles understood from this comparison, a wideband very efficient monopole-driven linearly polarized antenna was realized. The interdigitated element was divided in half and set onto a large ground. This electrically small antenna system exhibits two deep overlapping resonances resulting in its wide fractional bandwidth of 17.4%. Its radiation efficiency was 95%. The animated surface currents at two resonance frequencies are still associated with the fundamental loop current mode and antiphase first higher order mode respectively. Circularly polarized electrically small antennas are highly desired in practice. Another orthogonal interdigitated element and split-fed monopole structure were introduced into the linearly polarized design. This electrically small circularly polarized antenna has a wide 3 dB axial ratio bandwidth of 8.6% and a high 88% radiation efficiency. The surface currents are also plotted to confirm the fundamental loop current mode and the same antiphase first higher order mode behavior. In summary, interdigitated magnetic-based near-field resonant parasitic elements were utilized to realize several wideband highly efficient, electrically small antennas. Compared with the original antenna, the bandwidth of the monopole-based linearly polarized prototype was significantly enhanced by a factor of 11.6. Its Q ratio value was also reduced by a factor of 3.32.